Okay, so now we're on the air. Yay! I don't know why it worked this time. Okay, let's keep going. Do you want to keep going?
Yep.
Okay, that was number 1. I am recording now, so from 2 on should be fine. I do not know what's happening, but we're not going to complain, right? Okay, what was number 2? Sketch the graph. It's the same question, right? I mean, it doesn't ask all the details, but really, if you're going to sketch the graph, you should know the vertex, the max, min, all that stuff. However, this time, why is this question more difficult? Yeah, this is not in graphing form, right? So it makes it a little more challenging. We could do, I don't know, there's lots of ways we could do it. We could kind of start finding the x and y intercept, I suppose. It's nice to put it in vertex form. What would be your strategy? What would be your go-to? What would you do? Would you put it in vertex form? Or do you want to just try x and y intercepts, or what?
This is quadratic, and then I found the x-intercept.
Okay.
Not the x-intercept, the x value for your vertex. And then
Okay.
we do it to a.
Oh, I see. Okay.
And I substituted the rest on my actual vertex.
Perfect.
And I got an
All right, so Eduardo's telling us a whole bunch of great stuff. What you can do is the x-intercepts can be found by just using that minus b over 2a, right? You don't even have to use the whole quadratic formula. I suppose you could find the x value of the vertex, right?
Yeah.
Then you use the quadratic formula to find the intercepts, right? Okay, so we will use the quadratic formula to find the vertex. Or sorry, to find the x-intercepts. I was going to say, and who was that? You just asked me, Spencer, you just asked me, I think they've started giving me the quadratic formula on the pre-cal sheet, by the way. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, okay? I think that formula is now given to you on the formula sheet. However, you have to know what a, b, and c are, right? So when I look at my question, this is my a, this is my b, this is my c, right? Okay, so let's see what we got here. X equals the negative of b, which would be 6, plus or minus the square root of b squared, so 36 minus 4 times a times c all over 2 times a, right? All right, so this is a really quick way to get our x-intercept. They're tougher. Y-intercepts are easy. Agreed? Actually, if this is our question, this is what we were given, right? We were given y equals 3x squared, minus 6x plus 4. This is a harder thing maybe to graph, but this is the easiest form of giving for a y-intercept, right? Because what's my y-intercept? 4, right? It's just your constant term. Because if I put a 0 in for x, this term disappears, I'm left with 4. So it's the x-intercepts that are always the problem. And although this is a difficult formula to handle maybe, it's guaranteed to give you your x-intercepts, right? It's foolproof. So I get 6 plus or minus the square root of, what do we have? 36, subtract, this doesn't look good, does it? So what do I get? I get 36 minus 4 times 3 times 4. Uh-oh. All right, well, all is not lost. What does that mean? I'm getting a negative under a radical sign. That just means there's no x-intercepts. Is it possible for a parabola to have no x-intercept? Yeah, for sure, right? It could be one of these. So it can be like that, right? Be like this. So it's for sure it's possible not to have x-intercepts. Will a parabola parabola always have a y-intercept? Absolutely, right? It will always cross, even though mine don't look it, because I'm not showing the y-intercept, but these arms, remember what we said, they keep growing out, eventually they'll cross, one of them will cross the y-axis. So they'll always have a y-intercept, but not necessarily x-intercepts. Okay, so no x-intercept. My y-intercept in this form is easy to see. It's just 4, so that's good. All right, I'm going to see what I can see. And then we also have to find the vertex, right? And Eduardo, you already did that. I know you used your slick minus b over 2a.
Yeah. And then once you find the value of the x for the vertex or whatever, you substitute it back into the original equation to get your y.
Yeah, so 1, 2, 3, 4. So here's my y-intercept. I know that's a point. Okay, so now part of when you're given your equation in this form, your ABC, I've got my a is 3, my b is -6, and my c is 4. The vertex, I'm kind of all over the place here, I think. The vertex, or I guess I should say the x coordinate of the vertex is whatever is minus b, the opposite of b, all over 2 times a, right? And that's just a fact. So x equals the vertex, x equals, well, negative b would be +6 then, right? All over 2 times 3, which is 6 divided by 6 is 1, right? So the vertex, the x-coordinate of the vertex is 1. Then the y-coordinate will be, okay, well, we'll just figure out what y is. Y is equal to 3 times 1 squared minus 6 times 1 plus 4 equals, okay, can I do this in my head? 3 minus 6, -3 plus 4 is another 1.
Yeah.
So the vertex is 1, 1. All right, does that help me? 1, 1, yes it does. Because this is the, and I know it's opening up, agreed?
Yeah. Well,
Okay. So if this is the vertex, this is the turning point, right? This is where the graph turns around. So I know that if I have a point over 1 up 4 on the left-hand side of the vertex, I'm going to have an identical mirror image point on the other side of the vertex, right? So I can go over 1 up 4, or sorry, up to the 4. And I don't know, how do you guys feel about drawing a parabola with only 3 points? Would you do another one?
we could do like a table of
Yeah. And not, yeah, and, or like pick one other point, right? Just to kind of get an idea of the width. So, Joanna, can you suggest another? I'll help you. But I think I want another point just to maybe see how wide it goes. So I know that my parabola is kind of starting out like this. Let's pick a point kind of over here maybe, right? So give me another x value, Joanna. This is 1, 2. So give me an x value larger than 2. 3, okay? Okay, so let's say find the y value when x is 3. Okay? You've got your equation, right? Don't forget this is what you were given to work with. This gives you the relationship between x and y, right? So y equals 3 times, Joanna picked 3 squared minus 6 times 3 plus 4. Notice I can pick any value of x. X is the boss, right? X is the leader, so you're always picking values of x. I can pick any value of x to substitute in this equation. One of the reasons I said to Joanna is pick any value to the right of 2 is I kind of steered us to positive numbers. It's always easier to work with positive numbers than negative if you have the choice. So always kind of pick a positive if you can over a negative, it's easier. And not going too big, right? Because sometimes you're not going to have your calculator as a tool. And like for the whole exam, you don't have a calculator. So don't pick like 19, right? You're going to have to square 19. That's not really going to work, right? Well, for us today, we have our calculator. So what, 3 times 9, 27 minus 18 plus 4. Alrighty. What do we get? 13. So y equals 13. Okay, that gives me some kind of indication of where I'm going to go, right? When x is 3, 1, 2, 3, y is 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and I'll have another matching value of 13 over here, right? One more over. So that tells me this is a really skinny, tall parabola. There you go. Okay, my work is not, usually I'm more organized than this on a paper, but there's stuff all over the place. So when you're graphing, here's a couple little tips. When graphing, you need, I guess when graphing a parabola, which is the shape we call a quadratic, you need x-intercepts, if there are any. For any graph, you should show the x and the y-intercept. The y-intercept, the vertex, okay? And we'll just say at least one other point as needed. Kind of a good rule of thumb, right? We're going to be doing graphs of many types of functions in this class. Quadratics and linears are something you're supposed to know already, right? Okay, quadratic, and I do have it being recorded, so these notes will go up on the blog. Let's try, I'll go through 3 and 4, or partially anyway. For the quadratic equation, x squared minus 4x plus 6 equals 0, find the value of the discriminant. The formula for discriminant is equal to b squared minus 4ac. It's just that little piece, you know what it is? It's that little piece underneath the radical, and some people figure that out first to see if it's negative. And if it's negative, you know there's no x-intercepts, right? So let's see, find the value of the discriminant. Okay, so b squared, the discriminant equals, okay, b squared minus 4 squared minus 4 times a times c. So it's going to be what, 16 minus 24? Negative 8. Okay, I got a negative discriminant. A negative discriminant, a negative value for the discriminant means there are no real roots. No x-intercepts. Intercepts and roots refer to the same thing. Roots are kind of like roots of an equation, so when you're solving something using algebra, and x-intercepts are obviously what we refer to those roots when we're putting them on a graph. Okay? I'll talk quickly about number 4D, but I don't think I'll do the whole thing. I'm not going to graph number 4 because I already graphed 2 quadratics. Okay? So the interesting thing is, this is what a bulk of your grade 11 course was, by the way. Given 2x squared plus 5x minus 3 equals 0. This is called a quadratic equation, right? Because it has the x squared in it. And what you spent probably half of your grade 11 course on was working with this equation in every possible imaginable way. Basically what you were doing is you were solving for x, okay? So we want to solve for x. And why we want to solve this equation for x is, I'm going to kind of try and give you a big picture of this whole pre-calculus study. So when you have 2x squared plus 5x minus 3 equals 0, we want to solve for x because that equation represents something you're studying, right? Any math equation is basically, it's a solution to a mystery in the world, right? We don't know. Quadratic equations are things in our world that mostly we can think of them as projectiles, right? Things that go up in the air and come down, like rocket ships or people. Or in business, there were a couple people studying business, right? Business applications, sometimes your business makes money, and if you're selling a product, you keep making money, and then you know what happens sometimes? You reach the tipping point and people stop buying your product, and then what happens? You start to lose money, right? The profits go down. So in business, that's why calculus is part of business. It's because you're doing lots and lots of math calculation, and you're trying to find that perfect number, right? That perfect selling point, or the perfect amount of money to throw into advertising for marketing, right? Because the more money you spend on marketing, the more people are aware of your product, and the more they're going to buy it. But what happens if you start to put too much money into marketing? People might start to get turned off and kind of get sick of your product, right? So you're always trying to find that sweet spot. Well, business applications can be represented by a quadratic equation, right? So, on paper, on our system, this is what our quadratics look like, right? In the real world, if you're studying business at Asper, I mean, they do things other than quadratics, but they're not really interested in these areas, right? They're just interested in the positive areas, right? Positive numbers, because positive amounts of money to be spent. But in pre-calculus, because we're abstract, right, we deal with the negatives and the positives, and then part of the application process is just focusing on positive numbers, okay? So anyway, in pre-cal, we learned how to solve quadratic equations, how to solve for x. Remember when you first started in school, you started with like baby equations, something like this. Here, I'll do this again. Kind of match. Okay, if I told you to solve for x, how would you do that? How would you solve for x? Isolate x. So I move the 6 over, right? And then divide by 2, so I get -3. Okay, so linears are really easy. By the way, I could actually graph this. I could graph this on a graph, and I could find my x-intercept on the graph, and that would be a solution. If I give you this, though, as soon as I give you something like this is linear. This is harder, right? It's quadratic. I can't isolate x anymore, can I, Eduardo? Because I have an x and an x squared, and they don't go together. So I had to learn different systems of solving the equation. So you know what we did? We gave you a whole bunch of tools to solve this equation. All the ways I can solve quadratics. To solve a quadratic. Okay, what are the ways we can solve a quadratic? To find out what x is. Yeah, for me, the easiest way is factoring. I like factoring. But what happens for some of your quadratics when they can't all be factored, right? So then your teacher taught you. Oh, yeah, the square. That's really, I would never do that. I know you had to learn in grade 11, but if I couldn't factor, I would just jump right to the formula. But you're right, you did complete the square, which is why it's on your review sheet. I would do this or this. And what's another way I could solve this? It's not the best way. But that would lead you to what? Why are you doing a table of values? Graphing. Now, why isn't this a great idea? Like, this is actually a great idea in the real world. That's what I wanted to talk to you about. I remember there was something. Why isn't, like, I just showed you a graph. We did 2 graphs of quadratics. That's why graphing quadratics were a big deal, because it's another way to solve for x. What are the downfalls of graphing, though?
The numbers get absurdly big sometimes.
And real world problems don't have values of like 1 and 3. Another problem of graphing is you have to have a pen, you have to have graph paper, and the biggest one is what you mentioned though. Real world problems don't have, your answers aren't always going to be x equals 3, x equals 4, right? They're going to be x equals 1.324 or x equals negative 0.057, right? They're going to be real numbers, not integers. So that's a big problem. But what I wanted to tell you, lots of times you're going to have graphs, especially our first unit's going to be all graphing. I hope you guys, I know a lot of you have smartphones, so if you have smartphones, please use them in the classroom for graphing to check your graphs. Of course, for your actual tests, graphing calculators aren't allowed, right? But or for the exam, but for homework purposes and to understand concepts, graphing programs are great. You can either use a graphing calculator or something I'm sure you're familiar with is Desmos. So I'll refer a lot to Desmos too. It's an online graphing program. So graphing is a great way to solve if you have access to technology, right? And in the real world, like if you actually end up going through aspirin, getting that marketing job, you're going to be using software and stuff, right, to solve problems. So Desmos is great. I'll show you on Monday how to use it. We'll be using it a lot for the first chapter, like in a classroom setting, just to understand concepts. But anyway, that's why linears were so easy to solve, right? Isolate the x, find x. As soon as you get to quadratics, it's a whole different ballgame because I can't isolate the x, right? They're not like terms, and there's an x spread and an x. That's why you learned all the other techniques. And quadratics are what you learned in grade 11. And in grade 12, we do cubics, cubic equations, quartics, quintics. Oops. So that means you're going to have like a linear, the smallest form of a linear equation would be just like y equals x, right? That's the simplest linear equation. Cubic or quadratic in this, sorry. In grade 11, y equals x squared, right? If it had an x squared in it, that's quadratic. Cubics are cubes. Quartics are, okay? So you can see why we have to have more sophisticated ways to solve, and then we stop at cubics here, right? Those are the polynomial equations. And then we also study in grade 12, old stuff you're supposed to know. You should know a rational equation. What does a rational equation look like? It looks like that. Starts as a fraction. What does a radical equation look like? What's a radical sign? Right? You probably call it square root sign, maybe. What are the others? Abdul, what else do we study in 4 days pre-cal? Can you remember?
Sinusoidal.
Sinusoidal. Okay, so you have to know what these guys look like. Did you know these guys have graphs? You don't just use them in right angle trig cos of x. What else are we missing here? Oh, exponential. Actually, we don't do circles. We do circular functions, but they should know what that one is. Exponential, that is y equals something like a 2 to the x. And then we do logarithmic as well. But my point is, you're always going to be wanting to solve, like we're solving equations, and there's always two approaches in math. Math is like a dual approach to any problem can be used, the algebra way or the graphing way. And you're trying to find the solution to a problem, and either way is acceptable. Pre-cal leans more to the algebraic way because the graph we do is just pen and paper. It can be a little imprecise, but you have to know that the two can go together, and they're not contradicting each other. You should get the same solution whether you approach the graphing way or an algebra way. Anyway, questions about that? But when I ask you to do factoring, complete the square quadratic graphing, it should all come to the same answer, right? They're just different approaches. And one of the reasons you were exposed to all the approaches in grade 10 and 11 and then in 12 is the more tools you have, the more approaches you have. When I asked you guys, oh, how did you start this graph? Eduardo piped up and said, oh, I used the quadratic formula to find the x-intercepts, and then I found the vertex. He could easily have started using another tool, right? He could have tried to factor. The more tools you have, the easier you're going to find your job, right? Because you have the right tools in front of you, or you can use different tools, whatever you find easier. So let's see what else I can get through before the time is up. So for this one, does this one factor? Does number 4 factor? Let's see, I think it does too. I have 2x squared plus 5x minus 3 equals 0, right? If you need help with factoring, factoring's a big deal in pre-cal, come see me and we'll see what we can get from you. So I know my first term has to be 2x and x, right? I think my next one is a 3 and a 1, plus minus. 2x squared plus 6 minus 5, and then I get a negative 3. Okay, what factoring does, it takes a polynomial and it turns it in from a normal, like from just a polynomial written in simplest form, and it factors it, it turns into a multiplication statement. So I have this term multiplied by this term equal to 0, because I'm trying to find the x values that make the y 0, right? I'm trying to find the x-intercepts. So that can only happen if 2x minus 1 is equal to 0, or if x plus 3 is equal to 0. The only way I get an answer of 0 in a multiplication statement is if one of the partners equals 0. So that tells me if I move the 1 over and divide by 2, x equals a half, or x equals negative 3. So when y equals 0, x equals a half, or x equals negative 3. So I know that the x-intercepts are half and negative 3. Okay? So we say the roots of the equation are 1/2 negative 3. That tells me the x-intercepts are half and negative 3. That was part A. What if we did this completing the square? Let's complete the square, even though I would never suggest you do that. Okay, let's see if we complete the square. So I had 2x squared plus 5x minus 3 equals 0. So what do I do to complete the square?
You bring the 3 over.
Yeah, I got to bring the 3 over. But this is going to be a nasty one, isn't it? You know what? I'm going to say it's not worth it. Omit. Omit completing the square. It's just not worth it. Let's do quadratic formula though. X equals minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, so I got my, so x equals minus b minus 5 plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay. So x equals minus 5 plus or minus, I think we're going to get a positive number here, 25 plus 24, I think that's 49, right? All over 4, which is nice, sorry. So I get x equals minus 5 plus or minus the square root of 49 is 7 over 4. So x equals, okay, minus 5 plus 7 over 4, or minus 5 minus 7 over 4. So x equals negative 2 over 4, right? So it's negative a half. What did I get positive? Oh yeah, positive 2, thank you. Or x equals minus 12 over 4. Okay, so x equals a half. X equals negative 3, which is what we got here, right? We got it through factoring. We got it through quadratic formula. Remember I said I always prefer factoring? If I can factor, it's way quicker than quadratic formula. And even me, like I made some stupid mistake here, right? The harder the formula is, the easier it is to make a silly mistake. I should have let Abdul do that one. And graphing. I don't want to graph this one again because I've already graphed a couple of quadratics, right? If you've been working through this, is there anything else that angles in standard position? I kind of showed you the answers, so I don't know if that means anything to you. Anything else you want to talk about before the weekend starts? We've got about 10 minutes. If you flip over the page, is there anything that looks really strange to you, or you want to talk to me about anything? I'm not taking this in or anything, right? This is for, the answers are here, but obviously go home. There's lots of websites too. You can Google help for math.
So I will do it as I think that's the same as the regular school.
Same thing.
First we school deliver. I will do the same as the regular school, right?
Yeah, you're doing the regular high school program. Yeah. Yep. Yep. This is just, we're just a regular Winnipeg 1 high school. It's just that we just teach adults. But it's the same curriculum and everything's the same. Okay, so everyone's got course outline, everyone's got practice. I will post those